Good morning, all. Today we will learn about stack and queues. So in this lecture, we will start from implementation first, right? How you can implement stack and queues. Then we will see observation patterns, like how you can observe any kind of question where you can apply stacks, right? Usually it deals with arrays basically, like arrays question. Usually you can make it more efficient using stacks or queues, right? According to the need. So we will see how to observe those questions and then apply stacks, right? That's a really important thing. And then we will do questions. I will do one question where you can, where using that you can solve most of like 70% questions of stack and queues, right? After that I will tell you how to apply that one question to other questions. Fine, is that fine? So let's start with implementation of stack using array. But first, what exactly is a array? Sorry, what is exactly a stack? So have you seen stack of plates? Like let's say that this is a basically container. You need to put some plates. So you will put one plate here, then next plate will come on the top, right? If you are putting it from in this way, it will come like this, right? So basically, now if you need to uh, take the plate out, right? So you will take the plate out which is at the top, right? You can't take the plate out which is in this in the beneath of these plates, right? You need to take the top first. So in this way, like this will get removed, this will get this will get removed. So this kind of follows like last in first out principle, right? Last in, so basic, that's why stack is last in first out, right? Last in, last was in, first was. That's why stack follows LIFO principle. Got it. Now we will see how you can, how basically in coding stacks are used, right? So for that also I will just like we will go to the implementation first, like later on. But first we need to understand this, right? So basically the codes, these things are, I mean, uh, a little bit language specific, but I will just teach like how what should you know basics first. So let's say that you have written push 6. You have defined one stack, right? Let's say that how to define stack. You can say stack, right? And in this you need to mention the data type of what kind of data types you are putting in your stack. Let's say that we are putting numbers, so we will write stack int. You can name it as s. So this stack will be created, and this will be named s. Got it? Now if we say that s dot push, let's say s dot push 6. So what will happen? What will happen? Six number will be here, right? 6 will be pushed. Now again, after this we say s dot push some other number like 3, right? So what will happen? What will happen? Simple. 3 will be pushed like above it, right? Now again, let's say we say s dot push 7, right? Now what will happen? We will 7 will be pushed out. I mean pushed in, right? Now there's one function, there's one basically there's one thing to note. Top. This top, in CPP we use top, in I guess Java we use peak, right? So basically if we call top, right, in the function body or in the main code, then the top element will be output. So here what is the top element? 7, right? Because it's at the top, so 7 will be the uh, output of top, right? Now if now next, if we say pop, pop, just pop, right? What will this do? This will pop out the first element only, because in the stack, let's say like I defined, right, you store the plates and you need to take out one plate, right? It's this pop means you need to take out the plate, one plate. So that will be the toppest one, right? You can't, in this case you can't pop the third three, right? Hence the 7 will be popped out, and after pop, the new stack the new stack would be basically 7 will be popped out, right? So this will be the new stack, right, after pop function. Got it? It's simple. And then after, if you call top again, then what will be the output? It will be 3, because now the new top is 3. It's This is the simple basics of arrays, sorry, stacks, right? Now we will learn, okay, let me just, now we will learn this thing, like implementation, basically. Now we will start with the implementation. Fine. Now, let's say that we have array. Fine. Array, we have array, and we have some space. Let's say, oh, why it is, yeah. Okay, let's say that we have one array. Fine. And we have some array of one particular size. Let's say 0, 1, 2, 3, 4, size 5. Right. Uh, now, now, uh, how basically stack works with array. So the top, there will be one top, let's just imagine there will be one top, and that, wait, let me also write that this will be -1. The index, this will be -1, like just like before the array even starts. And then there will be one variable, let's say top, which will point to -1 index, which is empty. Basically, there is nothing in the array, right? There's nothing in the array, right? Now, if we do, if we do, just hold on. If we do push 6, if we do, let's say, push 6, then what will happen? We need to push this into the, basically what we are doing is that we are using arrays, right, just to visualize stacks, right? That's why we are using arrays. So top will be here. Now whenever we are pushing it, whenever we push it, we can shift our top. Let me make it an one element. Okay, yeah, that's fine, that's better. When we are doing push, right, when we are doing push, we can say that uh, we have our top, basically we have our top to be shifted here, and 6 will be here. This is what exactly push 6 means, like this top will be shifted here. So basically what this means is that in this stack we are just push 6 element, which is the top, right, top, and this is only the one element in the stack, right? Simple, nothing, there's nothing much complicated. Now if we do another, similarly if we do another push thing with 3, what will happen now? Okay, starting from here, if we push 3 in this stack, what will do? 3 will be here, so new top will be 3, right? So hence here in the array, the top will shift here and 3 will be entered. This is what exactly how arrays, you can implement stacks using arrays. Fine. So this is what basically how we can implement using this. Now if let's say now we need to pop, yeah, now you need to pop, let me, yeah, now you need to pop out, let's say just you need to pop out. Then what will happen? Basically in the stack, what we how we pop out, we take out the 3, and then the new top will become the 6 will become the new top, right? So what will happen? Easy. We can we can just take out this 3, right, and the top will be minus minus, right? You get the point. It's just a pointer which we are playing according to the theme, right? So summarizing this thing, we can say we can say that for, okay, wait, we can say that for push principle, for push principle, what exactly is happening? Top is top plus 1, right? Because whenever we are pushing, the top is shifting height, right? Yeah, that's why this is the thing. And array of top, right? Because let's call it array of top will become the new element. Basically when we are pushing, the top element will become the top, right? So that will be, we will assign, right? Now coming with pop, right? How is pop getting summarized? We can say top is equal to top minus 1, because the index is basically when we are just shifting the top here, it just means that the new top is this, right? And let's say that we need to find the size, let's say we need to find the size, right? So this is also easy. We can say top plus 1. Why top plus 1? Very easy, because here we have top at 0, right? So there's only one element and we start from 0. We start from 0 index, right? So indexing wise 1 plus 1 we are doing. Fine. Now again, let's say that we need to make one more function. Basically these are all the functions which we can make using stack. We need to make empty function, right? So when this will be true, let's say is empty, is we need to make is empty, right? When the array, when the stack is true, easy. If the top is equal to -1, then just return true. This is what easy, right? Because in this case, in the first case, we found that our top was at -1, right? Our top was at -1. That's why the new, which meant that the stack is empty. Hence, these are the functions which you need to basically know. Fine, using stack. Now let's get to implementation of queues using arrays. Right now we will learn about what exactly is queues. Right, we'll just go like this in this way only. Most of the questions are I mean it the stack and queues, there's one only one principle which is kinda different, but basically they are very similar. So let's say that, have you been to, it's just like a normal queue. Let's say that there's one ice cream shop, right? There's one ice cream shop where ice cream is made. Fine, where ice cream, you have some ice cream and all, right? And now there's one queue of people, right? There's one queue. So let's say that this guy is standing at first, right? Let's say one there's okay, let's say that there are three people. Fine. Now there's a queue. Now if if you are going, like if you see like there's a good ice cream shop and people are standing here, you will get into the queue from the last one, right? Right. And if this guy gets its his ice cream, he will go out, right? And then this guy will come, right? So basically what is happening is that it is kinda, it like the first one is it is basically this follows FIFO principle, which means first in, first out. Basically what, if let's say that if this queue was empty, the first guy would have came first and left also first, right? So first in, first out. This is what basically a queue is, right? Now we will learn about how you can uh, basically uh, use this thing in code, in like basically in coding, how this helps. Let's say that we have you can imagine like basically you can imagine it like a stack, or uh, to avoid confusion I will also use this thing, right? Okay, let's say that you do push 2, you do push 2, right? You do push 2, this will get here. Fine, that's fine. You do push 4. Basically, let's say that this is the entering point, this is the exiting point. So you pushed 2, so 2 will get pushed. You push 4, you 4 will be pushed here. You pushed 3, 3 will be pushed here, right? Now let's say, now if you do top, basically the functions of stacks and queues are very similar, right? Now you do top. Ideally what should have been the case in the stacks, it should have been 3, but here since it is queue, the top will be the 2. So hence this top function will return 2, basically, which is the first element in the queue, 2, right? Because this is the first, like in the queue this is the first one, right? This guy is the first one, hence top will give us 2, right? That's basically a cult difference between stacks and queues, right? Now we will start with the implementation of queues, right? We'll go again, we'll use an array. Fine. Here we will have, basically we will have one count variable as well, which is first 0. Fine, we'll have one count variable which is first 0, and I can say this again, let's make it an good array, right? 0 1 2 3 4. Fine. uh, with this we will have two more, two more pointers, which is front and rear, right? Let me also make them single a single variable, right? Yeah, now this is how we will initialize our array if we are want to implement a queue out of it, right? So we have front, we have rear. Fine. These both will point to first, like, zeroth index. We have nothing in our basically in our queue, right, in this case. So basically they are both pointing at one thing. Now let's say that we do push 3. We do push 3, right? So what will happen? What will happen? It's easy. We will have 3 here, but the rear will go in the next one. As we are pushing, it's a thumb rule again. As we are pushing, we will make our rear to go ahead, right? Because let's say that this is a queue, right? So 3, the rear, basically, when we say 3 is the front, right? Basically, why we are writing this front? Because when we are popping, the front will be the case, right? We will do array front, that will, get us our popped element, which will be the first element. Hence 3. Since 3 is the new element, the rear will wait for another element, or maybe if there's nothing, then it will be nothing, right? Hence rear will be after 1. It will be shifted after once, right? Now again, let's say that we do, let's say, let me remove this. Let's say we do push 2. Fine, let's say we do push 2. So 2 will be here. Fine. And rear will be shifted again. Fine. In this way, it will be shifted. Also, as we, okay, I literally forgot this. As we are pushing 3, let's say we have pushed 3, so we will also increment count, our count also. Now if we have pushed 2, let's say 2, so this, as the rear is going ahead, as we are pushing, we will also have to update our count. We will get why we are using count again. Now let's say we have done pop, we have done pop. Fine, we have ran pop. So what will happen? Basically, the front element will go, right? When we are doing pop, the front element will go. Hence, this, we can say, this front will be then incremented to 2, because the new front will be become 2, right? Because you saw this, right, in the stack. The 2, when 2 gets removed, 4 comes out at the first, becomes first element, right? So the new front will become 2, and we will erase this, right? We will just erase this is gone, right? So this is how pop and uh, uh, these things works, right? And as we are doing pop, we will decrease our count. So are you seeing one pattern here? Like, in our first case, count was 2, so there were 2 elements. Now they are again 1, so, count is 1, so they were only one element. Hence count can be used to find the size or the number of elements in the stack at current, right? Hence count is really important, and we will use it more often later on. Now let's say you do some operations, right? You do some operations and you got this 2 1 8 random numbers I'm just putting. So let's say you do this 2186. As you are pushing, your rear will go ahead, and when you are when you have pushed when you have pushed the last element when you have pushed the last element, the rear will go to out of index, right? It will just point to fifth element. Let me just write fifth index, which is nothing, I know, but just for visualizing stake, actually becomes a circular queue in this case. But I'm but now we are using a array, right? Hence I'm just using the fifth one, 5 6, right? So if you want to search more about circular queues, you can, you know, explore using any kind of GPT or Google out. So basically, circular queue, it's circular queue. It's just in the name, but basically this is what follows. Like, in a circular queue also, this is what follows. I will show how, right? Because you might be confused, right? Because circular queue, if this is a circular queue, right? The elements, if I enter one more element, it should come here, right? So using array, I will tell you how this is happening. Fine. Just wait. Now I will tell you how. Now let's say that rear is at here. Fine. Now you can, now if you want to, again I will just write it from now let's say that you need to define top function. How you will define top function? It's easy. Array front, this will be the basically top function, right? If you're writing top, this will be uh the code of it, right? Top, basically arrays, the array front is the top one, right? See, top, it's in this array, in this queue, 2 is the first one. So array front top, when we are saying the top, the peak, the first one, it will be the array front, right? Now let's say that this case, and okay, this also, we have count also. Count will be like 4 because there are 4 elements, right? I told you. Now let's say that you need to, there's one more operation came of pushing 9, right? Now you are saying, okay, where will I push 9? Because rear is at here, and basically when we were pushing, we increment and we place 9 here, but there's nothing here, the array ends, right? Still n is 5 and count is 4, so basically count is still less than the number of the size of the array, right? N is the size of the array, right? So there's possibility to add another element, but how we will figure it out? It will be added here, but how we will get it, right? What we can do is that we can simple, it's really, you just need to just run this thing. We can say, we can have one rear percentage of n is equal to, basically we can use this thing. Let's say rear is at 5, right? What is rear? Rear is at 5 modulo n, number of size, which is 0. It gives out 0, which means that after this we need to push 9 at the 0th index, so hence we will push it at 0th index. This is what basically how we will do this. And as the 9 comes here, we will our shift our rear to 6th. Yeah, exactly, right at 6th, right? Now let's say we do pop, we do pop, right? We do pop. After pushing 9, we do pop. What will happen now? We will shift our front, and this will get empty, right? This will get empty. Now again, let's say we need to push 10. What will happen now? Rear is at 6. Again, this rear, this will run. Rear is at 6 modulo n. What is the final output of this? 1. So basically, hence 10 will be placed here. Are you seeing the pattern now? Using this thing, we can push, we can we can use this thing to push our elements. Fine. So now writing proper codes for this thing, basically now we are writing push and pop codes uh, for q. Let's say that we have one function, push q, push x. Let's say push x, push, it takes x element. So we'll first write the base case, like if the count is equal to n, return -1. Why is this case? I told you that, right? If the count, and also as we are increasing, we also need to update it, right? So when the count becomes 5, which is equal to size, the array is full, right? So we can't enter any more element, hence you need to return -1. Simple, right? Now we again will apply that thing only, like rear modulo n. Basically for pushing, we need to check, we need to see, this will be the new index. And as we are pushing, what we are doing, rear plus plus, and also count plus plus. That's all. Exactly, that's all. Because when we are pushing, this pushing thing will work for every like if we run this, it will work for every push, or every push code. Right, now let's say that we do pop. Let's say that we do pop x. Fine. Let me change the alignment. Yeah, yeah. Let's say that now we need to write pop. We need to write the pop function for this. Right. Let's say now again, if the count is equal to 0, which means that there is no element, then just return -1. Fine. Again we can do front modulo n, just to check it's the same principle. And when we are popping the element out, we can do front, and we can use the count minus minus operation. Why we have done this, why we have done this thing, just to check if, like, like if you try run this again to pop an element, basically this will just, when we are popping, we are not returning anything, right? Hence I have written -1. So it's that easy, it's nothing much of difference. Now also, uh, push operation top, now top is left, right? So top, how you can write the top function, you can say if count is equal to 0, basically there's no element, then just return -1, right? There's nothing and as I told you, return a front. Basically the front always points to the top of the stack, or of the queue, right? Hence these will be the functions which you get from the queues, right? So really important, you need to understand all this. Fine, so just make a note out of it. And yeah, that's all for implementation of queues and arrays. Now now important bit comes here now. uh, just hold on. Yeah, now important thing comes out. Now we will learn about identification. We'll learn about the identification of, like, how you can identify, how you can observe the questions which can be used, which can be solved using stacks or queues. Fine. So uh, I will just give you like one scenario, right? Basically this deals with first point of identification, is that most most questions have arrays, like questions which use arrays, right? They they can be used by stacks. Fine, this one identification, I'm like, this won't give you much clue, but whenever you see arrays, there's kinda possibility of maybe 60% possibility that that can be solved with stacks, right? In some way, it can't be most of efficient one, but in some way it can be solved, right? Now this first point doesn't give you much hint, right? Like, okay, I saw one array question, how can I apply stacks, right? Now we will see on second point, which is like, which gives you 100% surety that that will be applied, that can be solved using stacks, right? Let's say you have, let's say you have one, you solved one array question, fine, using a brute force method, where you have defined uh, two loops. Let's say I 0, I is less than n, I plus plus. Fine. And then another loop you have defined inside it. Right. Let me put. You have defined inside it in j is equal to 0, j is less than n. Again, just see the pattern. I mean, just see the loops first. Right. You can see here in this thing, you can see that, let's say I draw one timeline, right? The time, so 0, this 0 and n elements, right? So how will I iterate? I is going to 0 to n, right? And how is j iterating from j, like if we say j minus minus here, right? Now so j will go from n to 0, like it's going to this, or if we say j minus minus, let's say j minus minus, it is going till SR, like this way, right? It's going to whole thing. So we can say I uh, j is independent of I, right? When they are independent of it, you can't use stacks, right? I mean, uh, like, it's not possible, basically. Maybe you can use in some way, but it's not highly advisable. Like if they are independent, right, then don't use stacks, right? Now it's there's no point of using stack, basically. Now let's say you have another but there are some questions where you have used brute force method, uh, and this is giving you some on square, right? But in this question, this is what is happening. This is what is happening. J0, it but j is less than I, right? Now, is j independent of I? No, because here if I again draw this timeline, 0 n, right? Now this is some I. Now I can go from here, I can go from here. I basically I basically I is running from I to n, right? But j can go, j can basically complete halves of it. How? Let's see. Like, say, see, like j can go, there are four ways. J can move to 0 to I to n, right? N to I, or I to 0. Right, when I to 0, it is j minus minus, basically this way. When n to I, n to I again, it is j minus minus this way. I to n, j plus plus, 0 to I, j plus plus. Basically, I'm just, pointing out in what ways j can iterate. But since it depends on I, it depends on I, right? In these cases of on square, when the inner loop depends on I, it's like 100% possibility that stacks can be used. So this is how you will, like, this is a 100% possibility. Like, if you see any question and basically j term is depends on I, 100% the stack can be used, 100%, right? So this is like trial and tested method, basically. So 100% possibility that stack can be used. So so this is what, like, my motive was to teach, that you need to learn how to get that approach, and then you can maybe do the questions, right? So this is the pattern. Now I will we will start with one question, which will basically is a, it's kind of a question where if you do it, you can solve most of the questions of stacks, right? So the question goes like this. Yeah, so using this question, you will exactly get like what I was implying last, like, abhi recently. So question is called nearest greater to right, right? Or it is also called as next largest element. Basically, this is what. Just hold on. Yeah, this is basically a category of question. Using this, you can solve any kind of like question related to stacks, right? So this is what basically, these are two uh, different things. I mean, they are like called differently, but they are basically same thing. So I will like explain the problem to you now. So basically, what exactly this means. Let's say that we have our array, right? We have an array, and we have one, 3, 2, 4, right? We have 1, 3, 2, 4. That's fine, right? Now we need to check next greater to right, next greater to right for each element, right? So let's say that, for considering for 1, what is the next greater to right? What which element we need to return, the element which is next greater to right of it. So we will, our search space would be this one, I mean, considering space, and we'll see which is the next largest element, which is 3. So this will be 3. Got it? Got it? Now considering for this one, let's say this one, what is the next largest element to this 3? Is it 2? We'll search for these two. Is it 2? No, it is smaller than 3. Is it 4? Yes. So this will be 4. Again, this for 2, it will be again 4, right? Because this is the it's exactly the largest, right? Now 4, it is at the end and there's no element in here. Hence this will be -1. So this will be the output of it. This will be the answer. Got it? We need to basically we need to make this thing. Let's say that I am taking one more example. Let's say we have 1 3 0 0 1 2 4. Fine, we have this thing. Now we need to find same thing. Right, now checking for this. What should be the next greater to right? Which element should be the next greater to right of this one? 3, right? Which should be this one? Is it 0? No. 0, no. 1, no. 2, no. 4. 4. This will be 4. Now consider for 0. This will be 1 directly, right? Again for 0, we will search these three. Which is the next greater? Exactly next greater. Why we are not writing 4? Because we need to see nearest. Nearest. Which is the nearest greater to this element? 1. So 1. Again for this 2. Now 2, 4, and since this is the last element, hence minus 1. This is what we need to return. Got the point? This is what is the question. Now here we will use stack. How? Let's find out. First, what should be the brute force method for this one? Let's see. Let's see. We have this. Fine. We have this, and let me enter the numbers also. 1 3. I will take that example only. Fine. 1 3 0 0 1 2 and 4. Fine, this is our array, right? This is our array. Now we need to, let's say that we need to see the brute force method. What can be the brute force method for this? We can have simple, we can have two loops, right? We can have one I, we can have one j, which starts from, basically we need to compare both the elements, right? And then we need to move, right? So we can start j from this, and we are starting I from this. So what can we, so we are not, we will be just seeing what is happening here. We can write the loops. We will just write the loops, right? What will be the loop? Quickly let's write. Right, what will be the loop? It will be for int I is equal to 0, I is less than equal to, let's say, n, right? N is the number of arrays, sorry, the number of elements in the array. Now inside the loop we will have j, which will start from where? Just after I, right? So I plus 1, I plus 1, j should be less than n, j plus plus. Why I plus 1? Because we need to compare, we are having two iterations, right? We need to compare both the elements. If it satisfies, then just see this 3. If not, move the j ahead, then check with this one, then do like this. Hence we will be writing like this loop. Now again, the point which I covered earlier, what was the point? Second point, right? Most questions, arrays, yeah. So if j depends on I, stack will be 100% used. It can be, so basically for now the time complexity would be O of n square. We don't need to write the whole brute force method, right? We can just see this thing. We see, oh, j is dependent on I, j is dependent on I because j is I plus 1, right? Hence we can apply stack here directly. We jump to optimize method now. In the interviews also you can just apply this. You can maybe solve this question brute force method, but then you can say, I can use stack here. Fine. So how you can use stack here? Let's see. Let's take one example again. Same example maybe. Yeah. 1 3 0 0 1 2 4. Now I won't do for the whole array. Let's start from, like, starting. Let's say that this we are considering this, right? We need to see which is the next greatest element to right of 3. Is it's actually 0, no, 0, no, 1, no, 2, no, 4. It is 4, right? So how you can get this 4 as an answer? You can use stack here. How? Let's see. We can have one stack. Let's say we have one stack. Fine. Now now we have to put the elements in the stack in the reverse method. Why? Let's say that we start from 4, we see 3. Okay, we start from here, we put it in a stack, right? 4, now 2, now 1 0 0 till here only, right? Now starting from now we need to compare our this element where the pointer is, where we need to consider, we need to find the answer to the top of the element. Hence the top is like, here, and we need to compare, so we need to start comparing from the nearest one. Hence the nearest one should be at the top, because in stack we have the access of top element, right? Hence we are iterating with like in this way, like 4 to from 4. Now see, 3 we need to compare, what we need to compare s dot top with, is s dot top is equal to, is greater to array of I, which basically means this is the array, and this is the ith element which we need to find, right? We need to compare this with this. See, 0 is s top greater than 3, no, pop it out. New stack will have only these elements. Now is 0, no, pop it out. 1, pop it out, no. 2 is greater, no, pop it out. Now which is left? 4. Is 4 greater? Yes. Then what? Just return s dot top. Got it? Simple. Else, if the array is, if the stack is empty, if let's say if empty, then just return -1. Done. Got it? And if it is smaller, actually it should be like in this way. Let me correct it. Let me correct it. If s dot top is equal is greater than array, then just simple return if else, if s dot top is smaller than array of I. What you have to do, you need to pop it out so that you can test, right? You need to pop it out, you can test the next element. Then, like, else, when there's no element left, then just return -1. Got it? This is how we can use stack to get the 4 here. Got it? This is what basically how we can use stack here. Yeah. Now let's see how you can, solve further on, like the full question, because now here we need to basically make an array, right? We need to output a proper array, 3 4 4 of each element. Right now let's see how you can do that, but using this principle only. This is the sole principle. If you understood this, I guess it would be easy later on, right? So again, let's see, we have one, let's take a shorter array this time. Let's say we have this 3 3 2 4 1. Fine, we have this 3. Our I pointer, uh, let's say it's here. Fine, let me also make it on in one element so that's easy to shift. Yeah, so this is the thing, right? Let me little bit make it shorter also. Yeah, so this is the array, right? We need to, what exactly we need to output? We need to output what? We need to make this as 3 4 4 -1, right? Basically this is what we explained, right? I explained here how it is 3 4 4 -1. 1, it's small, greater, next greater element is 3. This next greater element is not 2, 4. So 4 2 4 4 is -1 because it's the last element, right? Simple. We need to output this way. And let's say we have our I here, and we have our stack. Now using stack, I will visualize. Basically this is what we are doing to code, right? This is what we are following, this approach to code. Fine. Now we can have one vector. We can have one vector. We can make vector, or if you are using Java, you can use another data structure. But let's say we have vector, and we are making one vector here. Uh, Let me make it little bit better. Like this. Yeah, this is the thing. And here we have some vector which is like basically for now this is a, when we are starting with a vector, this empty, there's like -1. Let's put -1 for now. Fine. So we have this thing, we have this case going on right now. So uh, we have -1 because vector is empty for now. Fine. And also in these questions the last element will have -1 only because it's the last element, right? So -1 for now, -1 we have b, right? Now we will shift our I, but as we shift our I, we need to push that element where the I was pointing to, so in the stack. So we will push 4. Fine, just to check. Now like as I said here also, we will start from reverse, hence I is starting from here. Got it? Simple thing. Now we will do what we will do. Now we will see, we will check if uh, 2 is like basically if 2 is smaller than the top of the stack, yes, it is it is smaller, so we will put the 4 here. You're seeing the pattern now. What we are seeing, minus 1 4, we are getting same thing, right? Now it's done. Now we will shift again I here, and as we shift we need to push the element here too. Fine. Now checking if array at I, this thing 3, is comparing is smaller or greater than the top of it. Is it like, is the top greater? No. Then if it's not greater, then just pop it. Pop it out. Simple pop it out. Remove it. Fine. We have removed it. We have removed it. I have removed it. Let's say I have removed it. Fine. Now, now check again. Is the top greater? Yes. Then if this satisfies, then just push the same element in the vector. Right. Again, we are getting the same thing here also. Now putting basically as we shift I, put the 3 here and just check for this one. Is again compare array of I with s dot top. S dot top is greater. Hence, just again put it in this way. We got the answer, but in reverse. So it's easy. It's easy basically. What you can do here, you can just simply maybe use reverse function. You can use reverse function. You can say we begin, basically the beginning of array, change it to beginning of end, then return v. Done. Your answer is here. See how easy it got, how easy it became with stack. You got this point? It's very easy. The stack, using stack, you can do like any question very easy. Now let's also write like as what just to summarize what we discussed. Let's say that like before even writing starting coding, we need to find we need it's better always to get write all the edge cases, right? So let's say if the stack is empty, what we need to return, just minus 1. Fine. If the stack is empty, just return minus 1. If the top, if the s dot top is greater than array of I, what we need to do, what we need to return, s dot top. Basically we are pushing it, right? Now if s dot top is smaller than array of I, we need to do two operations, right? When it is smaller than I, we need to first check if stack is empty first, like it can be empty. If it's empty, then just return minus 1. Or we need to what, we need to do, we need to pop it out, not top, we need to pop it out. Pop. Got it? Basically pop, and then just and then uh okay, wait, we need to check if it is empty after it is popped, right? We can't, like, obviously it won't be empty. If we have an array element, it won't be empty. We need to first pop it out, then check if stack is empty. If it is empty, just return minus 1. If it is not empty, then you have your answer. You can check greater is top greater than a. If it is not, again pop it, right? You need to do this again and again. This is what basically we need to consider in our code, right? So let's start coding as well. Fine, let's start coding as well. I will just code this solution. After that, I will tell you approaches, then you need to code it out yourself. Fine, but for now this is a new thing, so I will code it out. So what we are doing this here, we are defining one vector, right? We define our vector which takes int v, right? Let me shift it here. Yeah. We are also defining one stack here, right? Which takes element s, I mean integers and s. Now we are starting our iteration in reverse order, right? In reverse we started. Wait. In reverse we started, right? In here we in reverse we started, right? So it's I will be n minus 1, the array size minus 1. I is greater than or equal to 0. I plus plus. Simple, simple stuff. Now we do if s dot size is greater than equal to 0. Basically, if the size of the stack is greater than or equal to 0, what we do? We just push back. We just push back our minus 1. Basically, this is what the push operation is, right? We can use pushback or you can use push for Java. Let's stick with pushback. Fine. Now let's else if s dot size is greater than 0, which means that stack is not empty, and s dot top is greater than array I, which we are finding out, right? Greater than array I. Then what do you do? Simple. You just push back in the vector the s dot top. Basically, what we are doing here, wait, yeah, we are considering this thing s dot top is greater than array I. Basically, if the array I is, like, let's say in this case, in the 2 case, 4 was the top, right? So just push because it's greater, it's the next element and it's greater, so just push. Then done, these two elements done. Now now we need to find one more. Now last else if statement is left. S dot size is greater than or equal to 0, which means it's this element is stack is not empty. We do s dot top is greater or equal to array of I. Why I have written greater or equal to array of I? If if we have similar elements, let's say that if we have 3 as well, we need to consider for that only, right? Let's say we had limited element, let's say we have one more other 4 here, right? And 4 comes, so we need to basically consider for that only also, right? We can't do the operation pop again, hence we are writing array of equal to, right? If it is also equal to, we are considering all cases, then we need to basically run this uh, while case, right? While case we can run, and we can say uh, s dot top is basically equal to array of I. Got it? If that's the case, then just s dot pop. Basically, if the array is smaller, right, is the top smaller, then just s dot pop. Your while condition is over. Now check if s dot size, again, if s dot size equal to 0, just push back what, -1, right? -1 we need to push back if the array is equal to this. Else else v dot pushback, what, v dot pushback s dot top, because we got our next greater element, that's why we are writing this. Also, as you are pushing back, sorry, as you are iterating through the for loop, let me also use this thing. This else is for this else if while is only this much, and this for loop comes till here, right? Like, and as we iterate through the array, we need to basically, as we were shifting our I, we need to push the element in the stack, right? Hence, in the end of the for, like inside the for, directly we can write array of I, because we are always pushing the array, right? Now you can just end the brackets according to your convenience, and the code you wrote, and this is the code, basic code. Simple. It's actually really simple. If you go again, if you just revise it again, it's really simple. You just need to compare and do the operation. And this question, this was what was this question? This was uh, next largest element, right? Next largest element. Now you have many variations of this. Like, let's say this was next largest element, next greater to right, next greater to right. It was next greater to right. Now there are another 4 combinations of it. We can have next smaller to right, right? We can have, what else we can have? We can have less smaller to left also. Yeah, exactly. We can have multiple combinations of this same question. But again, if you, like, let's say if we have next smaller to left, right? We need to see left. Then how will be the iterations happen? It will go from here, right? Iterations will go from here, because we need to check the elements which are greater than, but in the left. So you can just use the same code and tweak, right? You can just tweak according to the question, and then yeah, one more combination is left. Great Greater to left. Yeah, these are the combinations, all the possible combinations. If you know this one, you can do all those 4, and using these 4 combinations only, we have a lot of questions that you can do directly, right? It's just copy pasting the same stuff, just tweaking a little bit, and then you have the question solution, right? So this is what basically how we solve the next. You can use this, you can do this homework. I mean you can just basically you can just use the same code and you can apply everything for this thing homework. And I have one more homework for you. The homework is valid paren parenthesis. These two are the homeworks, right? These two are the homeworks. Let me also. These two are the homeworks. I mean, these questions are the homeworks for today. Now, let's solve one more question, which which is like totally different thing. But now, as you know how and when we are applying the stack, you can solve this question as well. And it's like this question is really good question. So please, uh, you know, uh, please have pen and paper and like write the solution or code the solution like with me only, right? So the question is it's very popular as well. You may have heard about this stock span problem. Fine, this is a stock span problem. Yeah, stock span problem. We in this thing, let me do this. We have this array. Let's say we have array. Fine, and we are using 100, 80, 60. I will use the same example which was in the question. Wait, yeah, so 100, 80, what is next, 60, 70, 60, 75, 85. So basically these are the stock prices of different days, right? 0, 1, okay, not 0, 1. Let's write like different days basically, right? These are the stock prices of a particular stock, uh in a different days, like day 1, 2, 3, 4, 5, 6, 7. So basically day 1 the stock price was 100, 2, 80, 60. It's varying, right? Exactly how stock works. Excuse me. Yeah, so now what you need to do, you need to find consecutive consecutive smaller or equal before it before any stock price at that day, at that day, basically consecutive smaller or equal to before any stock price at that day. Let me give you the solution as well. So what we need to output, what we exactly we need to output, let's see we we need to output how many like basically let's say considering from going from here 85, right? We need to see what is the consecutive smaller or equal to before any stock price that day, right? Before that day. So we need to see, is this smaller, consecutive smaller or equal before it, like before, is it smaller? Yes, it is smaller, so tick 1. Is it smaller? Yes. Is it smaller than 85? Yes. Is it smaller? Yes. Is it smaller? Yes. 1 to how many ticks? 1, 2, 3, 4, 5. But also in the question it is written consider smaller or equal before it. So we will also consider 85, and for 85 the answer would be 6. Got it? For 85 the answer would be 6. Again let's do for every element, right? So 85 we got 6. Right, now for 75 we will see stocks before or equal. So 75, first of all, it is we need to return equal also. So considering 75, right? 75 is 60 smaller, yes. 70, yes. 60, yes. 80, no. Stop. Exactly, stop right here. Or maybe check. It's not. Right. So how many ticks? 1, 2, 3, 4. We will have 4 ticks. So 4. Got it? Simple. Now checking for 60. Again going for 60. How much? What all elements are smaller? 70? No. So don't take it. 60. It is equal. So first of all, start from 60. It is equal. 60 also equal. Then 80? No. 100? No. Right. So how many elements? How many elements? It is it one? Wait, I think I have written. So here we have only like two elements, which is like basically smaller. But you can't write two here. Why? It is written consecutive and 70 is between. Hence, when we need to break out, we need to basically return when next element is greater, right? So we can't consider this, and 60 only is left. Hence, we will write 1 here. Got this? Got it? Now 70. What is the consecutive to it? 60. So yeah, 1, 2 basically, right? So the answer will be 2 for 70. 60, it's nothing, 1. The answer will be 1. 80, 1, because 100 is 1. 100 is not nothing, so 1. But we could have written minus 1, but the question says equal also, so we can consider 100 and run 1. So basically this is what we need to return. This is what we need to return. 1 1 1 2 1 4 6. Let me check. Yeah, this is what vector, in form of vector, we need to return. Got the question? Got the question? Right. Now, if you have if you have understood these four problems, you can pick, you can think for a while, which of these things you can pick to solve this question. It's exactly the same. I mean, I'm like, trust me when I say this, it's the same thing, same code we will copy paste from here and use this, right? Just little bit tweaking, and then just think out of these four which can be useful here to solve this question. Okay. uh if you still didn't get, I mean, you could have understood, but it's fine. So let me still do this. 80, 60, 70, 60. Right. So we can we can use nearest. So the basically what we can use is here is that we can use nearest greater to left. We have to use this thing, nearest greater to left. Just imagine, right? What we are doing here, we are finding nearest because it is asked consecutive. Nearest greater to left, we have considering left. It's equal to, it's equal, so we are left, we are considering left, but it is smaller, so why we are using greater? Let's see. Let me explain you how. Okay, so let's consider from here. We need to find next greater to left here. What is the next greater to left for 85? Is it 75? No. 60? No. 70? No. 60? No. 80? No. Which is 100? So 100 is the greater one, right? So you write 100 here. Okay, write 100 here. So can you see the number of steps here? What exactly we need to do here? 85, we need to find consecutive smaller. So these all are the consecutive ones, right? Or equal before any stock price. So this was 6. So the number of, we need to basically return the number of elements between the, I mean the bottle, the limit to it. Like 100 was greater, right? So 1 2 3 4 5 6, right? So can't we do something as 6 minus 0, or maybe basically the index and something 0? Can't we do that, like 0 1 2 3 4 5 6? See, 6 minus 0, we get 6. So for 85 we were also getting 6. So this is how you need to check the pattern here, right? This is how you need to check the pattern here, right? And if you are doing the next greater to left, so you are basically using stacks, so basically it makes sense, right? So in conclusion here, just to for your understanding, what we can write here is that, what we can write here is, we can write consecutive smaller or equal before it can be equated, can be made equal to what? Nearest greater to left, but only index. We will use index. Now I will explain how. Let's say one more time we do this thing. Okay, let's see one more time how we can get that particular full vector which we need to find, right? Let's say we have one, uh, we have this input, right? We have 100, 80, 60, 70, 60, 75, 85. Got this. Let me also use this thing. Fine. Uh, Also let me write indexes 0, 1, 2, 3, 4, 5, 6. Now we have vector, which basically means that we are finding every element's next nearest greater to left, right? Nearest greater to left. Uh, how we can do this? Let's think how we can do this. How we So now basically what we need to do is that instead of again here instead of instead of printing out the 100, the number itself, the element itself, we need to basically assign the index of it. Like if it is 100, index will be 0, right? So we need to find 0. Hence we can say 85, it would be 0, because the next greater to left is 100, which is at 0, right? For 75, which is the next greater to it left, it is 60, no, 70, 80, so it will be 1, because 80 is at 1. 60, similarly for 60, which is greater 70, which is at 3, hence you will write 3. Similarly this will be 1, 1, 0, and since this is the last element, hence minus 1. Now you see there's a some vector which we found basically using the nearest greater to left, but not the element. We are finding index of it, right? We have found index. Now to get this array, get the answer array, this 1 1 2 1 4 6. Can you see something which we can do? Can we do this 0 minus 1? Let me write answer. Can we do 0 minus 1, which is 1? 1 minus 0, which is 1. Let me write it in this blue. The final answer. 1 minus 0, 1. 2 minus 1, 1. 3 minus 1, 2. Right. 4 minus 3, 1. 5 minus 1, what? 4. 6 minus 0, 6. Is it matching with the answer? 1 1 1 2 1 4 6. 1 1 1 2 1 4 6. Now you got the point. We need to somehow find this array, this V array, right? And then we can simply subtract the index of each, and then done. We got the answer, right? Simple. It's actually really simple. What we found out, like we saw, we need to find consecutive equal, right? So we can say next greater to left, because before. Now we know how to find this 100, right? With that code we need to find 100 because it's greater to left, so we do this. But instead of writing returning 100, we just need to return index. We saw index, if we subtract we get the answer. Got the point? This is what we need to do basically. So so starting from now, we can, I guess, start finding writing the code. So for now we will write, we find first, we need to find the v vector, right? V vector we need to find, like if are able to find this v, it's done. Simple problem done, right? But some little bit tweaking is left. Also in the stack, in this stack, since we are not only just getting the num element, we also are, using the index of it, right? Hence in the stack, how we will deal with this thing? In the stack, we need to form we need to do this we need to basically do this: next greater to left 1 with its index 1, then next greater to left 2 with its index 2. Basically, why we are doing this, we need to make a pair, we need to push a pair in the stack, so that we have both the next greater to element and its index. That's why we have to use pair. Hence this stack will input some kind of a pair, right? Hence we can define it in this way. Let me write it. Now we can, I guess, start the coding part. See see it's very easy. Now I will uh, I will first define stack, right? But the stack is kind of different. So we can have one pair which takes int both numbers, right? And this, and we can define it as s only. So this is how we have defined a stack which takes an input of integer and integer, right? Now since this is the simple, basically we are finding, we'll use simple this code only, greater to left. This, the question which we did here, this was for the greater to right, right? So we just need to change the iteration part, and then we will get the code of next greater to uh, left, right? This is next greater to right. What changes we need to do? It's easy. We need to, first of all, vector is defined. We need to, instead of starting from basically, if you do the question, if you do the next letter to left, you will find out this code which I will write. Instead of basically iterating the I through the end, we need to iterate through the starting point and I plus plus, right? If size this, push back one. If size is greater than equal to this, I guess these are very similar then. Basically s dot top should be array of I. Yeah, this also makes sense. Makes sense. S dot top, I think only the iteration part we had to change because it was next letter to right. Now we have next letter to left. Only this thing we needed to change. But the stack here has to a pair, right? And we are finding one vector v as well, right? So what changes we need to do? Let's see what changes we need to do. First first instead of, basically instead of uh, push, whenever we are pushing back, we are pushing a term, a pair, right? So instead of pushing this s dot top, where else is s dot top? S dot top pushback, it's also s dot top, we push back s dot top dot second. So basically we are pushing back the index, right? So hence we can write s dot top, s dot top dot second. This, in this way we can just push the pair, which we can just push the index of it, right? So hence we are writing here s dot top push, right? And also instead of where else is the s dot top, this also we need to change it to s dot top dot second. Fine. Also while comparing, now we can't compare the index, right? We need to ultimately compare the element of it, right? 100 or else. Hence s dot top is as the top, as the arrays are, in a pair. Hence s dot, when comparing we need to write s dot top dot first, because in the pair first is element and second is the index, right? So whenever we are pushing, push the index. When we are comparing, compare the s dot top dot first, the element, right? Here also when we are comparing, dot first will be put f. I am writing f dot first put, and at the end, in the last, since this is a proper uh, a pair, hence we need to tweak something here also, which we will array of I and its index, which we are pushing back as the I point, as the for loop goes on. Only these much tweaking, and then done, we got our v. We will get our v, we will basically get this, we will get this array, we will get this array na, we will get this array, but we need our answer in this form. So what we did, what we can do, index minus v, right? Simple. It's really simple. Only one line is left now of the code to solve this question. Only one line is left, which can be written for int I is equal to 0, and we are iterating through the v dot size because we got the v vector, right? So we are iterating through v size, and as we get the element, just subtract I element from it, basically the index, and then voila, done. Return v. That's done. Exactly. This is what we need to do here, right? Vi minus vi. I minus vi. Basically index minus v ka I, right? 0 minus 1 minus 1. Sorry, 0 minus minus 1 plus 1. 1 minus 0, 1. 2 minus 1 1, so basically we are subtracting this to this, right? Hence we are written it in this way, I minus vi. Got it? This is the final code of this question. The final code of this question is this. We have defined a stack first, we have defined array, and then we took the that question next greatest to left, and we just did some tweaking according to the need, and then we got the question, we got the code of it. Got it? Now just to sum up this thing, just to sum up this question, I can like just summarize this question, right? We got we have one stack sorry, we got one stock span array, right? We got one stock span array. Fine. Then what we did we we basically saw that it asks for smaller consecutive smaller or equal, right? We need to find smaller or equal before it, right? We found this. Then what we did we we saw ngl index vector. We need to find ngl index vector, and then just what simple, just do I minus vi and return the v vector which we found. Simple. Exactly this, these steps you need to make sure you are following these steps. Done. Got this question. This is actually really important question, and you saw that, right? Like how we learnt one concept basically. Like first we learnt next greatest to light. We saw how you can make it to left. Just like instead of iterating from end, we iterate through first point, right? Because we need to find greater to left, right? Left. So we'll start from 1 2 3 4, right? If you can do all this homework, you can solve, you can find the pattern, then observation is required a little bit, and as you practice you will be able to do all the questions. So this was a really important question. Pair stuff was there. This is a really lengthy question, so please make a note of it, right? So uh, now let's do some different kind of question, which will be little bit like here you will use two stacks, right? So uh, minimum stack or min stack with extra space, that I will explain. So basically here in this question, let's say that uh, we have some array again, 18, 19, 29, 15 and 16. Fine. So basically let's say that we have entered we are entering all these numbers, 18, 19, 29, right? And uh, and as 29 is reached, let's say that someone like coded out pop, so you popped it out, right? So only 19 and 18 are left. 19 and 18 are left. Now we need to make one more function. Let's say it's like min. We need to find min le in a stack. Like after running this, we need to return 18, basically, because 19 18, which is smaller one, which is the smallest element in the stack, 18, right? So using by running this function, this should return 18, right? But as we discussed earlier, in stack we can only access directly the topest element, right? We can't even check or get this element. So how we will do this? How we will do this? Basically, which we need to find. So in this kind of stack, we need to. So basically, we have push functionality, we have pop functionality. So we need to make one more functionality, which is min element. All right, min ele. Let's call it min ele. So for this we have two ways. We need to do two things. We can have two stacks. Basically in this cases we can have two stacks to track. So one stack will be, let's say we have one s and another is named as ss. So one stack s will be used to basically just make these functions, which is for every other stack, push and pop. And another stack we will use for min L uh, function, right? So these two functions we will use one stack and another stack for this function to make this function. Got it? This is how we will make it. Now let's see how we can do this. Okay, yeah. So let's say we have two we have two stacks, right? One is named S, one is named SS. Fine. Now also writing this here: 18, 19, 29, 15 and 16. Fine. 18, 19, 20, 15, 16. Starting from 18, right? So first, as we see 18, we will put 18 here. Fine. We'll put 18 here. Also, we will put we'll check if SS is empty. It's empty. Just put it here. Fine. That's the first point. Second, coming to 19, we will see 19. Okay, we'll put it 19 here, right? And uh, we can basically see, we can check if let's say 19, if this element exists as here, if the first element is smaller or basically is smaller than this top element. It's not small, right? Like 19 is greater than 18, so there's no point of putting it in SS is, this stack is basically should have the smallest element only. All right, so we need to put only those elements which are smaller than the latest one, right? So 19, is it smaller than 18? No, then there's no need to push it to SS stack. Fine. Now coming to 29. 29, see, 29 is also greater than 18. There's no point of putting to SS. We'll just put it here. Now, let's say someone did pop operation, like in our case, someone did pop operation. We will pop it out. Now, we can, like, instead of checking S, we can just see which is the element at the top of SS. It is 18, and the smallest is also 18. So we just pop this out, SS, and then from via SS, we will get our answer. This is the basic operation. Fine. If you didn't get this, basically, why we are using this SS? We are using SS for tracking smallest element in S in this stack. Fine. This will have the toppest element of SS will have always have uh, the smallest one of the S, right? Let's see that after 29 we again start after 29 pop, we put 15. Fine, we have put 15. So checking 15, is 15 smaller than 18? Yes, it is smaller. Then push 15 to SS also, right? Now checking for 16. 16 you can put here obviously, but is 16 smaller than 15? No, then there's no point of putting SS. Now if I run min le again, we can just directly access SS, see 15. Even in this, the smallest one is 15, so we'll get our answer. Got this? It's really easy. Using two stacks, you can basically, one stack is we are using for tracking out our smallest element, and one is just pushing and popping operations. Got it? So hence we can start coding the solution out, right? So first of all, we need to define um two stacks basically, right? So which one will have S, and there's one more stack, right, which will be named as SS. Fine, according to the need. Now let's find the push operation, right? And it, let's say this takes A. We need to define the push operation in this case because this is like some special thing, right? This special case. So let's say we have uh, this thing, and S dot push A. Fine, we can push A as we get, but also we need to take care of the cases, right? If SS dot size, if the stack of SS size is equal to 0, or or if SS dot top, right, is greater or equal to A, right, greater or equal to A, we will consider equal case also. Then what you do, SS dot push A. Got it? Because like as in this condition, if the incoming array, if the incoming element like 15 in this case is smaller than the ss dot top, push it to ss as well. This is what I have written. Exactly as I am saying, I'm writing the code. Exactly the same thing. Got it? Now, else just return, right? That's all. I'm just like write return here. Done. Now writing for int pop. Basically, when in this pop operation, we also need to basically return the element, right? Hence, I'm writing int pop, right? Whatever the whichever element is popped out, we need to return that. So, if s dot size, again writing the base case, if s dot size equal to 0, right? Just return -1. Fine, because there no point, there's no element in the stack, there's no point of popping out. Just return -1, right? What you will pop out then? There's nothing. Let's say that answer lies in the s dot top. Basically, I'm just defining one answer f s dot top, because we need to compare it, right? How? Let's see. We pop this out. We pop the element which is the latest at the top, and then if ss dot top, basically in the minim array, in the next array, if this is equal to ans, right? What you do what you do you ss dot pop, you pop out the solution and then just return the answer. Basically what we are here doing is that when we are getting our answer, we also need to pop it out from this array as well, s dot pop, right? Hence we have to write s dot pop and return ans, because in the pop operation we need to get that, right? Now writing the final min le, right? This will be the our this will deal with the our main answer, right? The final answer. So if s dot size is equal to 0, right? Return -1, because again if there's nothing in the minimum min array, min stack, then no point. Else return ss dot top, because ss dot top will always have the minimum of the whole stack. Hence this is the thing. Got this? This is how, this is what the program will be. Using two stacks we can uh, solve this problem. Got it? So your homework, one more homework would be to find min stack, but using only one stack. Fine. This you can use any other data structure, but stack you have to use only one stack, or I can say um, min stack without extra space, because when we are creating another stack, it is taking more time or space complexity, right? The space complexity will be more, as in the question it is given extra space you can use. Hence I have used extra stack. But in this your homework, you need to find how you can use find without extra space, right? So uh, let me also summarize the homework part. Like, this will be the homework first. Now also these will be your homework, and two more questions I want to give, because the stack thing is really direct one, so there's nothing to much worry about, right? Uh, so this will be homework nearest, this nearest greater to right, nearest greater to left, nearest similar to 1. If I have done the nearest greater to nearest smaller to right, I have done one of the things. You just need to just tweak some things, and then you will be able to solve it. And one valid parenthesis, and one more question: implementing stack using q, this if your subject is basically, and vice versa, if your subject is computer science, in college level, they they make students to do these questions. So it was really direct. I wanted to teach something different today, hence I didn't pick implementing stack using q, because this is really popular and it's very basic thing. Hence I wanted to do something different, hence I didn't pick it. So this is your homework, right? Please make a note of it. Please always practice, and we will meet in the next class. Okay, thank you, bye bye.